Astronomers have finally identified where the Milky Way's star-making activity fades, uncovering a long-sought boundary in our galaxy. Determining how far the Milky Way extends has always been tricky because its disk does not end abruptly. It gradually fades into space. Now, researchers have identified a clear boundary for where new stars are actively forming. By studying stellar ages, an international team has shown that most star formation in our galaxy takes place within about 40,000 light-years of the galactic center. The team combined observations of bright giant stars with advanced simulations of how galaxies evolve. This approach revealed a distinct U-shaped pattern in the ages of stars, which marks the outer limit of the Milky Way's star-forming region. The extent of the Milky Way's star-forming disk has long been an open question in galactic archaeology. By mapping how stellar ages change across the disk, we now have a clear, quantitative answer. Galaxies do not create stars evenly across their disks. Instead, they grow outward over time. Star formation begins in dense central regions and gradually spreads toward the outer disk over billions of years, a process known as inside-out growth. Because of this, stars tend to be younger at greater distances from the center. The Milky Way follows this expected pattern, but only up to a certain point. The study found that stellar ages decrease with distance from the center until about 35,000 to 40,000 light-years. Beyond that, the trend flips and stars become older again as distance increases. This creates the characteristic U-shaped age pattern. By comparing this pattern with detailed galaxy simulations, the researchers confirmed that the youngest region corresponds to a sharp drop in star formation efficiency. This marks the true boundary of the Milky Way's star-forming disk. The data now available allow increasingly precise stellar ages to serve as powerful tools for decoding the story of the Milky Way, ushering in a new era of discovery about our home galaxy. If star formation falls off so sharply at this boundary, it raises an obvious question. Why are there still stars farther out? The answer lies in a process called radial migration. Stars slowly moving away from their birthplaces by interacting with spiral waves that travel through the galaxy. Similar to surfers riding ocean waves, stars can gain energy from spiral arms and drift outward over time. Most stars found beyond the boundary were not born there. Instead, they gradually migrated outward. Because this process is slow and occurs randomly over time, stars that have traveled the farthest distances tend to be the oldest. Importantly, these outer stars follow nearly circular orbits. This shows they were not thrown outward by galaxy collisions. Their current positions are the result of long-term internal processes within the Milky Way. The key point about the stars in the outer disk is that they are on close to circular orbits, meaning that they had to have formed in the disk. These are not stars that have been scattered to large radii by an infalling satellite galaxy. To identify this boundary, the researchers analyzed more than 100,000 giant stars. They used spectroscopic data from the LAMOST and Apogee surveys, combined with highly accurate measurements from the Gaia satellite, which is mapping stars across the Milky Way. By focusing on stars in the galaxy's main disk, the team was able to isolate the signature of inside-out growth and separate it from other processes that influence stellar motion. While the location of the boundary is now well defined, the reason for the drop in star formation at this distance is still unclear. One possibility is the influence of the Milky Way's central bar, which may cause gas to collect at certain radii. Another is the galaxy's outer warp, where the disk bends and could disrupt the conditions needed for star formation. Even though the exact cause remains uncertain, the study shows that the U-shaped age pattern is a reliable indicator of where star formation effectively stops. Future surveys such as FOREMOST and WEAVE will provide even more detailed data, helping astronomers refine these measurements and better understand what determines the edge of the Milky Way's star-forming disk. This work also highlights how stellar ages, once difficult to measure accurately, have become a powerful tool for studying the history of galaxies. By tracing how stars formed and moved over billions of years, scientists are gaining a clearer picture of how the Milky Way developed. Thank you for watching. If you've enjoyed our videos, subscribe to our channel for there's more to come.